Hey everyone, welcome to The Explainer. Today we're diving into a completely forgotten piece of web history, the obscure HTTP 402 protocol, and showing exactly how Cardano's recent V2 integration is resurrecting it to build a revolutionary machine-to-machine economy. If the collision of traditional web infrastructure and blockchain tech fascinates you, well, this is the breakthrough we've been waiting for.
Here's our roadmap for today. We'll start with the forgotten 402 error, move on to the X402 standard, and check out Cardano's unique integration. Then we'll compare core protocols versus extensions, look at the agentic commerce revolution, and wrap up with overcoming microtransaction hurdles. Let's jump right in.
All right, Section 1, the forgotten 402 error. This is literally web history, hiding in plain sight.
You know that frustrating 404 not found error, right? We've all ripped our hair out over that one. But right beside it in the HTTP specifications is the 402 payment required standard. It was actually built right into the early web, but it just kind of sat there, dormant. Why? Well, because the internet simply didn't have a native, decentralized currency to actually fulfill it. Until now.
Moving to Section 2, enter the X402 standard. This is all about supercharging HTTP. So here is how smoothly this completely removes the friction of paywalls. Step 1, your client pings a server for a resource, like a weather API. Step 2, the server blocks access with a 402 error, but actually provides a list of accepted crypto. Step 3, your client automatically pays. And Step 4, the server verifies it and instantly shoots back a standard HTTP 200 success code. Access granted, entirely natively.
Okay, Section 3. Cardano's unique integration, which brings us true native web communication.
This is a massive milestone. Cardano's version 2 schema has officially been merged into the main branch. This is a really big deal. It means developers working in Go, Java, Python, or TypeScript can now easily annotate their REST endpoints to explicitly require ADA or native tokens. Basically, standard web environments are finally talking directly to the blockchain.
Now, let's dive into a critical architectural difference here. Ethereum's EVM model often requires this high-friction allowance procedure where you have to grant a smart contract permission to touch your funds. But Cardano? It uses a native UTXO design. What that means is you, the user, securely sign the entire transaction context up front. The server absolutely cannot alter what you signed. It can only submit it. So you're left with zero security gaps.
This setup also opens the door for something called optional facilitators. Think about massive Web2 companies like Steam or big enterprise API providers. They really don't want the headache of managing blockchain settlements or rollback risks directly themselves. So facilitators step in as third-party verifiers. They allow for totally customizable security. For instance, a weather API might accept a fraction of a cent instantly via the mempool, while highly sensitive data waits for a full block confirmation.
Next up, Section 4, Core Protocol versus Extensions. Let's talk about organizing X402. So, by placing vendor-specific applications, like the agentic protocol Mazumi, in an extensions layer rather than the core protocol, X402 avoids becoming just a bloated mess. If every single project hard-coded their specific data into the core schema, the whole thing would break. Instead, the core remains totally open and chain-neutral, while specialized apps just act as modular, bolt-on upgrades.
All right, Section 5, the agentic commerce revolution. Welcome to the machine-driven economy.
This brings us to the absolute holy grail here, agent commerce. Just imagine a future where your software autonomously pays other software for resources without you ever lifting a single finger. It's like an AI agent hits an endpoint, catches the 402 request, pays from its own crypto wallet, and retrieves the data in milliseconds. This is literally the bedrock of an entirely new machine-driven economy.
Finally, Section 6, overcoming microtransaction hurdles. We gotta talk about the operational challenges. Okay, consider this multiplier, up to 35x. When it comes to the tiny microtransactions that actually fuel agentic commerce, Cardano's base layer fees are currently roughly 20 to 35 times higher than networks like Solana or Base. Now, for big transfers, who cares, right? But for a machine paying fractions of a penny thousands of times a day, that is a massive roadblock. So it naturally begs the question, if an AI agent only needs to spend a fraction of a cent for a single API ping, how in the world do we make these micropayments economically viable without base layer fees eating the entire cost of the transaction?
Well, the answer has to be layer 2. Developers are looking really closely at Conduit, which is the evolution of Cardano Lightning, and Hydra off-chain scaling solutions to absolutely crush those costs. There's also this incredibly clever Web 2 hybrid approach using JSON Web Tokens, or JWT. Basically, an agent makes one slightly larger on-chain payment and in return gets a JWT token for unlimited access to an API for, say, 5 minutes. Zero on-chain fees for all those subsequent pings.
I'm going to leave you with this thought, right from the developers. A multi-million transactions market at the moment. It means a lot for Cardano to be involved in X402. The standard is officially integrated. The infrastructure is there. But the true test is really just beginning. Will Cardano's Layer 2 solutions scale fast enough to dominate this rapidly growing machine-to-machine economy, or will cheaper chains steal the crown? It's a massive question. Keep learning, and I'll catch you on the next explainer.